In this video, we will study the inverse function theorem. This theorem allows us to determine under which conditions, given a function that I know is differentiable and invertible, will have also an inverse that happens to be differentiable. So the inverse function theorem is telling me the following, that if I know that f has an inverse and f is differentiable on an interval containing a, and I know that f prime of a is not 0, then the inverse is differentiable at f of a. And to prove this, we're going to have to go back to the definition of the derivative. So f inverse prime of b is equal to the limit as y approaches b of f inverse of y minus f inverse b over y minus b. And here b is a point such that b is equal to f of a. That means that f inverse of b is equal to a. Now, you see, because we know that f is differentiable on an interval containing a, f is continuous on that interval. So the previous theorem that we did in the previous video will tell me that the inverse is continuous at that point b, because remember, b is just f of a. So now that tells me that y tends to b implies that x tends to a. And we have the following, that the f inverse prime of b, which we said was the limit as y approaches b of f inverse of y minus f inverse of b over y minus b, this is equal to the limit as x approaches a of x minus a over f of x minus f of b. Here, thinking f of x is equal to y, that means that f inverse of y is x. F of a is equal to b, and f inverse of b is equal to a. So that's how we ended up with this. But now what I'm going to do, I'm going to massage this expression a bit to make that derivative of f happen somehow. So this is the limit as x approaches a of 1 over f of x minus f of a over x minus a. But you see, in the denominator, if I take the limit as x approaches a, that is just f prime of a. So that limit exists, so I am allowed to use the limit laws. So that gives me that f inverse prime of b is equal to 1 over f prime of a. Therefore, that limit exists, which means that f inverse prime of b exists, and f inverse prime is differentiable at b, which is equal to f of a. And that completes the proof of the inverse function theorem. And what this is also telling me is that I can compute the derivative of the inverse in a quite easy way, right? If I have that f inverse prime of b is going to be 1 over f prime of a. Now a, remember, is just f inverse of b.